Hey. The topic I am going to discuss is measurement of the spread of data using range, variance, and standard deviation. Spread of data. The spread of data, also known as dispersion, is a statistical concept that refers to how far the values in a data set are spread out from the mean value. There are several measures of dispersion that are commonly used in statistics, including range, standard deviation, variance, coefficient of variation, standard error of mean and variation of mean. Range. The range is a measure of dispersion that represents the difference between the largest and smallest values in a data set. It provides an indication of how spread out the values are and how much they vary from the smallest to the largest value. The formula for calculating the range is range equals maximum value minus minimum value. For example, consider a data set with the following values: 2, 4, 5, 6, 7. The maximum value is 7, and the minimum value is 2. Range equals 7 minus 2, equals 5. So, the range would be 5. Variance and standard deviation. Variance, V, and standard deviation, sigma, are two measures of the spread or dispersion of a set of data. They are related to each other, with variance being the square of the standard deviation. V equals sigma square. Variance. Variance is a measure of the spread of a data set that indicates how much the values in a data set deviate from the mean. The variance is calculated as the average of the squared differences between each value and the mean. Variance equals sum of squared differences from the mean, by number of values in the data set. The formula for population variance, sigma square, is sigma square equals summation xi minus mu whole square by n, where sigma square is the population variance. Xi is the ith observation in the population. Mu is the population mean. N is the population size. This formula measures the variability of a population. It represents the average of the squared deviations from the mean, where the deviations are calculated for every observation in the population. The formula for sample variance, S square, is S square equals summation xi minus x bar whole square by n minus 1, where S square is the sample variance. Xi is the ith observation in the sample. X bar is the sample mean. N is the sample size. It is similar to the population variance formula, but uses n-1 instead of n in the denominator. This adjustment is made to account for the fact that the sample mean is used to estimate the population mean, which introduces some uncertainty into the calculation of the variance. The sample variance is an estimate of the population variance. Example. Consider a data set with the following values: 3, 4, 5, 6, 7. Find the variance for the given data set. V or sigma square equals summation xi minus mu whole square by n. Mean of the data set, mu, equals 3 plus 4 plus 5 plus 6 plus 7, by 5 equals 5. Total number of values in the data set, n, equals 5. Sigma square equals 3 minus 5 square plus 4 minus 5 square plus 5 minus 5 square plus 6 minus 5 square plus 7 minus 5 square, by 5. Equals 4 plus 1 plus 0 plus 1 plus 4, by 5. Equals 10 by 5. So sigma square, variance, is 2. The variance gives an idea of the average squared deviation of the values from the mean, and a larger variance indicates that the values are more spread out from the mean. The variance is commonly expressed in squared units, which can be less intuitive than the original units of the data. To make it easier to interpret, we can look at the standard deviation instead. The standard deviation is expressed in the same units as the original data, making it a more useful measure of the spread or variability of the data. Standard deviation. The standard deviation is a measure of dispersion that represents the average deviation of the values in a data set from the mean. It is the square root of the variance and provides a more interpretable measure of the spread of the data than the variance, as it is expressed in the same units as the original data. Standard deviation equals square root of the variance. In the previous example, we have calculated the variance as 2. Now the standard deviation is standard deviation equals square root of variance, equals square root of 2, equals 1.4142. A larger standard deviation indicates that the values are more spread out from the mean. Thank you for watching. If you found this video helpful, please give us a like. Subscribe for more videos and also share with all your pharma mates. Thank you.